Assalamualaikum all dear students. Today we are going to learn about the MCQs for the topic of matrices. We are proceeding for the MCQs number 62. Let's start. If the order of a matrix is 4 cross 4, a matrix A, then the order of A inverse is equal to 2 cross 2 and B 3 cross 3 and C 4 cross 4 and D 5 cross 5. So here according to the definition of, if any matrix has order has 4 cross 4 means that they are n cross n. So the inverse of order is no change. We get the answer. A inverse is also the same order 4 cross 4 and n cross n. So the correct answer will be C. If we change the same question, 63 MCQs, if the order of a matrix is 3 cross 3, so the inverse of order, the order of n inverse is, here is also 3 cross 3, so there will be no effect in the order of, so in this question we will get the answer 3 cross 3. For 64, if A is equal to 2 minus 1 minus 2 1 5 8 9 1 0, then the minor element of 5 is 18 and B here is 10, C is equal to minus 18 and D is equal to 0. Now the minor elements of 5 here, it means here is this result is 5, so we expand by second row and second column, so we will get the here remaining term is 2 and minus 2 9 and 0. If we expand this term, so the result will be 2 and 2 0 and minus 2 and 9, so 0 we will get here plus 18 plus 18 will be the correct answer. So in that type of question we are expanding by the minor elements, cofactor elements here, expanding by 5 minor elements. So the second row and the second column we are expanding, so the remaining terms are 2 minus 2 9 and 0. So we get the multiply according to the formula AB minus BC. This is A and B and C expanding, and we are multiply these two terms, so we get 0 and minus is here. B is already minus 2 and C is equal to 9. We minus into minus plus 2 multiplied by 9 we get 18, so the correct answer is 18. For a non singular matrix A and B then A inverse B inverse is a whole inverse. What is the result? We get A inverse and B inverse. B is equal to B inverse and A inverse. C is equal to A and B, and D is equal to B and A. Look here, according to the inverse definitions, if we are, so the metric is a non-singular metric. Non-singular metric means that have a non-singular metric, so a determinant is not equal to 0, so that is called non-singular metric. And here we are using the property of A inverse. We can get this property. We are using B inverse and A inverse. Now, if we are applying on the both of type of inverse are available, so the same property if we are using here, so we will get minus inverse and minus inverse, A inverse and inverse. So we will get here B and A. So the correct answer is B A. D is the correct answer. The homogeneous system of equation Ax is equal to 0 has a trivial solution of has a trivial solution trivial solution f a determinant is equal to 0 and b a determinant not is equal to 0 and c a determinant and b is equal to 0 and d is equal to a inverse and a determinant is equal to not is equal to 0. So homogeneous system of equation is already given. At that time, the right hand side of the each equation must be equal to 0. For example, we are explaining 2x plus 2x1 and 3x2 plus 3x3 so is equal to 0. And similarly 3x1 and 2x2 plus 5x3 is equal to 0. So the right side of the equation must be equal to 0 and thus homogeneous system each power of the variable is also equal to 1 and has given that trivial solution means that here a determinant is not equal to 0. So the trivial solution giving that so a determinant if we are found so the result is not equal to 0. So the correct answer is B. The homogeneous system of equation Ax is equal to 0 and has a non-trivial solution. Has a non-trivial solution. So now the definition is changed and here A determinant is equal to 0. A is equal to 0. A determinant is equal to 0. Now the correct answer is that one. So the definition is changed and non-trivial solution is giving that a determinant is equal to 0. C7 F A B and C are n order matrices, then A, B, C determinant is equal to, what is the answer? So A determinant plus B determinant plus C determinant and B is equal to A determinant and B determinant and C determinant. C is equal to A, B and C and D is equal to none of these. So here A and B and C are n order matrices. So the order of each matrix is n cross n matrix. So A determinant we can also write in this form A, B, C. The given matrix we can write in this form also. So here is there a product, so we change the product of each one. Determinant of A, determinant of B, and determinant of C. So we can write this determinant A and B and C. So the correct answer is B. And what is the rank of A is equal to 138,000 and minus 148. So the rank of then A is equal to 1, B is equal to 3, and C is equal to 2, and D is equal to 0. According to the definition of the rank of a metric, we are using the rank of the metric is the number of non-zero rows of a metric is equal to the rank of the metric. This is the definition of the rank of the metric. If we are using what is the rank? The number of non-zero rows. The number of non-zero rows of a given metric is called rank of a metric. Rank of a metric. Now, according to this definition, the number of non-zero rows is one of that is non-zero rows, and the same third row is non-zero rows. But here, and the second row is 0 rows, so the rank of the metric is 2. According to this definition, if we are using the rank of a metric, so we will apply here this definition. And if a square metric A, then A transpose is equal to is called symmetric metric, and B skewed symmetric metric, and C Hermitian metric, and D diagonal metric. So now, according to this definition here, A dash represent as Hermitian metric. So the result is here we use Hermitian metric. My A dash represent here Hermitian, and if we take the transpose of that one, and we also the definition of A transpose of E metric, so that is symmetric metric. But here and the skew symmetric metric, if we are using, so A transpose is equal to minus A, so that will be symmetric metric, and that will be skew symmetric metric, and here A dash are used, so here the given metric is Hermitian metric. For any two matrices A and B, then A plus B whole transpose is equal to what is the result? So A transpose minus B transpose, B is equal to B transpose minus A transpose, and C is equal to B transpose A transpose, and D is equal to A transpose and B transpose. So according to the definition, if we are applying transpose in case of subtraction and addition, there will be no effect on the matrices. So we are expanding A transpose and B transpose. And this is according, so this choice is not available, A transpose plus B transpose. If we check the ARS change, so we can write this matrix B transpose plus A transpose. So the correct answer is C. Thank you very much for watching. Please subscribe my channel once again. Inshallah, we are going step by step on the topic matrices. Thanks once again.